Alright, so hello everyone. Thank you for joining this talk today. So yeah, I am Rommel, and I'm a malware researcher, and I'm based here in Singapore. So my talk today is entitled Internet of Things, Battle of the Bots. So to give you an idea, this talk is based on our research for the past year. And since we were monitoring Mirai botnet and all related samples to it. So let's take a look. So here's an overview of what we'll be discussing today. So first is a brief introduction of Mirai. Second is anti-analysis and encryption of its configuration if there are any changes. The next one is our lab setup and honeypot. So how did we get all the samples that will be presented today? And lastly is the Mirai variants. So we will compare them from the original source code of Mirai, then the changes of the variants. Then lastly is the popular variants. So the overview. So just to refresh your memory on Mirai. So we'll just take a look on some news that it made 2 years ago. So the first one is the attack on Krebs on security. So this guy is a famous journalist in computer security. And the attack caused the site to be offline for 4 days. And the record traffic was around 620 gigabytes per second. And next attack is against DIN, its infrastructure. So it made popular websites like Twitter, Spotify, and Reddit unavailable to users. So we can see already like the immediate impact of Mirai 2 years ago. So not only that, so another study showed that DDoS is also bad for businesses that are being targeted. So roughly 8% of DIN's customers base stopped using their services after they were attacked. So this was also a huge loss to DIN. The next, we'll talk about the first appearance of Mirai. So it was coded by Anna Senpai, or his AKA. And the source code was released in hack forums on September 20, 2016. So this is the actual post by Anna Senpai, and he also released the source code in this post. So the good news is, since certain information from this posting led to identifying the authors. So fast forward, after all the investigations, the author behind this Mirai botnet was pleaded guilty last December 2017. So when there's a good news, there's also some bad news. Since this is now open source, the source code of Mirai, so anyone can use it, including you or me, or like any cyber criminal can just reuse the code, and they can create their own botnet. So, and this cause, and maybe when they create their own botnet, they can also have the same impact as Mirai on what they did like to DIN and Krebs. So now this is the problem that we have, and many variants, or we can say copycats of Mirai, have been modifying the source code to infect more and more IoT devices. So we will take a more detailed look on Mirai variants later on. So if any of you maybe have looked at the source code of Mirai, so these are the main components included in the source code. So we have the command and control server, we have the report server, we have the loader, and we have the bot. So this bot here, this is the one that is installed in the infected device. So this is the payload. So this bot has 3 functions. First is the attack. So this includes the DDoS attacks. Next is the killer. This is the one functions to stop the processes, like maybe other botnets are running there, so it can kill those processes. Then scanner. So this is to infect more IoT devices. So it acts like a worm. So to have a better understanding on how the infection chain works by Mirai, so we start here, so the infected IoT device. So the bot module is installed here, and then what it does is does a telnet port scan. So it uses the default credentials. So it already has a list of default credentials. Then after successfully logging into that IoT device, it will report the IP and the credentials to the report server. So this was the other component that we mentioned. Then having the IP and credentials already, so we have here the loader. So this loader will be the one who will install the bot in the infected device. So now we'll have another infected device. So once this device is infected, it will just repeat the same process. So it will scan again some random IPs. Then if it's infected, if it's vulnerable, then it will infect this. And another thing, once it's infected, it will report now to the CNC server, like telling the CNC that this device is infected and it can already receive commands like whichever the CNC wants. Then next is we have here the botnet admin. So the botnet admin can sell or rent out the use of the botnets here. So he can rent it out or sell to a botnet user or let's say a fraudster here. So once the fraudster gets access to the botnet, he can send commands to the CNC server. Then the CNC server will send the attack commands to the infected devices. Then these infected devices will do a DDoS to its target. So basically, this is the infection chain of Mirai. And just to summary, so these are the attacks available to Mirai. So this is all in the source code. Then next is we have the anti-analysis and the encryption of the configuration table of Mirai. So this is the binary hex view of one of the Mirai samples that we encountered. So ELF, the header. So most samples is not encrypted by any custom packers like when we compare it to Windows. So usually it is just packed by UPX. So basically, if it's just packed by UPX, it should be easily be decompressed. But what the Mirai variants or authors do is they change this one. So this should be, the proper header should be UPX, exclamation point. But this one is changed by SNDJ. So what happens is, if we use the UPX tool to decompress this file, it will fail. So if we do automation, then it cannot decompress the sample properly. So what we do, we just change this value here to its proper header, which is UPX, and we are able to decompress it easily. And then next one is so not only SNDJ, we found that numerous values were changed in those UPX headers. So we have around 18 different headers that has been modified. So these are the lists. And if you have to give you an idea on the configuration table that we are talking about, so this again is based on our source code. So we have here is the CNC domain, we have the CNC port, the table scan domain, and the scan CB port. So for these values, in hex, these are the encrypted ones. So to decrypt this, when this is decrypted, you will get this value. So CNC change me. So for those variants, they just change this one to change their own CNC. And goes the same with the others. So how does the decryption of Mirai work? So let's take a look here about to decrypt. So basically, it has a table key here. So here, I just copied here to see clear. So this is a dead beef. So what it does, it's just use a XOR algorithm. So it's quite simple. So it XOR each byte of this table key. So if we XOR each byte to each other, we'll get a value of 0x22. And this value here, when we XOR it to the encrypted configuration table, we should be able to dump the configuration table. So an example here is the CNC port. So I showed it in the previous slide. So we have 22 and 35. So XORing 22 to 22 is 0. Then XOR 22 to 35 is 17 hex or 23 in decimal. So I computed this yesterday, so it should be correct. So next one, since we already know that Mirai just uses XOR algorithm, so these are the XOR keys that we were able to identify that Mirai variants are using. So approximately 47 different XOR keys used. And these are the top 5 that we found. So first is the dead beef or CRX22. So this includes Mirai. So we found that 27 variants are using this. And we have 54, 45. Then another interesting is this 0. So 13 variants are using it. So it means that the configuration table was not encrypted. So we can see everything, the CNC, the port that it uses. So we can see everything. Maybe it was used for testing purposes, or maybe they just forgot to encrypt the configuration. And next is catching live samples with our Honeypot. So we started a project last year in our team. So we call it the KAIB Project, or Kill All IoT Botnets Project. So we just use static analysis. Then we automate the decryption of the configuration table. So as mentioned, it just uses XOR algorithm. So it should be, we could automate this process. Then next is unpacking of known packers. So it just uses UPX. So we just decompress it UPX and see if the header is correct. If it's not, then we just change it to UPX. Then we will be able to decompress it. Then after decompressing it, we can get the configuration table. Then also we collect the CNC servers and the download URLs. So the result of this project for the past year, we collected around 21,000 samples. Then from these 21,000 samples, we got 15,000 samples that are related to Mirai botnet. Then next one is we identified 120 variants. So 120 variants is a lot. But I'll explain here how we were able to get this much. Then we have blacklisted around 500 plus command and control servers. So just an overview of our honeypot. So we use a low interaction honeypot. So we have here our product here. So we use FortiGate. So this is the one facing the internet. So every traffic that goes into port 23 and 2323 will be routed to our test network. So once it's inside the test network, so our FortiGate again or any router, it will direct the traffic to our virtual machine. So this virtual machine has two components. So first is the backend. So this one is the one that collects all the data from our honeypot, and this one here is the honeypot itself. So all the data gathered here, the samples, the URLs that being downloaded, will go back here to our KAIB system, and this KAIB system will be the one to analyze the data. Yeah, and then next, so how do we identify the Mirai variants? So originally, Mirai was named after by the strings or command this bin busy box Mirai. And Mirai applet not found. So this is not a valid command. So it is here since these are commands to determine if it has successfully brute forced its way to our targeted IoT device. So Mirai was named with this string. So the same with the variants. So we have here an example from a configuration table of a Mirai variant. So it changes this one. So bin busybox OOMGA. So we can just name this variant OOMGA. Then next, this is all the variants that we were able to identify for the past year. So this is a word cloud. So the bigger the word means that it has more samples. So it's pretty obvious already on who are the big names here, Sora, Owari. Then you can also take a look on some of them. Maybe you have encountered them or heard before, like Masuta maybe or Okiru. So yeah, these are all the variants that we have identified. So next slide. So this is the variant count. So before 2018, we only identified 14 variants of Mirai. But now, in the year 2018, it suddenly jumped 41 in January. So this also is in line since by this time, instead of using brute force logins, Mirai variants were using known exploits. So yeah, that was a big change. So we can also see the trend that it's going up every month. So by August, we already have 127 Mirai variants active. So here is a sample count for each month of 2018 that we processed. So January, we had 2,000. So if you can see, like every month, we almost process more than 1,000 samples. Then, for example, here at May, we only have like 1,405. So comparing it to the previous slide, so April had 76, but May had 81. So there was only an increase by 5. So it could mean that since there are only 5 new variants, then there were also less samples that were being processed. Then another example here is July. So this was the peak. So we had a lot of samples here. So as we can see, July here. So from 98 from June, it jumped to 117. So there were 19 new variants in July. So just last month. So now, just to filter out more the data, so we have a sample count per variant. So most samples are still in Mirai. So this shows that a lot of people or a lot of cyber criminals are testing Mirai. Maybe a lot of them are script kiddies who wants to learn using the bot, but a few are skillful on want to modifying the bot. So again, here we have the top 5: Mirai, Sora, Owari, Joshua, and Daddy L330. So now we proceed to the targeted architectures by Mirai. So all this here, the bot can be built. The bot can be built compatible for this architecture. So all of this here. So we have ARM, MIPS, SuperH, Spark, Motorola, Intel, PowerPC, AMD, and IBM. Then next, not only does Mirai variants add exploits to its arsenal, it also wants to target more devices. So by doing this, it adds a new architecture to target. So this is the International Arc Compact Processor. So this was discovered January 2018, just this year. So it was initially used by Okiru variant. And this was quite big news since around 1.5 billion products are dispatched per year using this processor. So if Okiru could infect like just a portion of these devices, then it could be a big botnet. Then after Okiru, so other variants also joining the Arc architecture. So we have these 6 here: Masuta, Omni, Root, Sauce, Chicken Inks, and Wicked. So now we'll take a look at the exploits. So it's quite a lot. So we were able to detect 28 exploits being used by the Mirai variants. So at least 16 of them are unauthenticated exploits, meaning that doesn't need to log in or doesn't need valid credentials to exploit an IoT device. So this is quite dangerous. Then 14 of the exploits are from 2017 and 2018. So for users that don't patch their IoT device, even though they changed their password, are still vulnerable by these exploits. So we have here the brands that are affected by the 28 exploits. So it ranges from routers, modems, CCTV, DVR, IP cameras, web apps, and also minor software products. So for the specific vulnerable product, maybe you can just check online on which product is vulnerable to this. Then now we'll proceed on the main variants by Mirai. So Satori or Okiru. So it was believed to be coded by Nexus Zeta. So this name was always in the configuration table. And this is one of the most popular modification of Mirai. So the loader was embedded in its bot. Then it included the architecture to its target, so as we mentioned a while ago. Then it uses exploits to spread. And one version of it mines cryptocurrency. So let's take a look at its timeline. So we first saw this on December 2017. So this CVE 2017-17215 from Huawei. So this is a remote code execution. So by that time, there were no details of this exploit. So we assumed that this vulnerability used by this botnet was a 0-day. And it was in fact a 0-day. And other exploits here are from 2014, from targeting the Realtek SDK. Then we have here the CVE 2017 from the Wi-Fi cam. So this one is also important since around 185,000 Wi-Fi cameras are vulnerable to this one, this exploit. And we have here the OS command injection to D-Link and HTTP basic authorization bypass in go-ahead webs. Then the interesting stuff in this one is this CVE here, right here. So it targets the Claymore miner software. So what the botnet do is it scans port 333. Then it targets the Claymore software mining. So what it do, it changes the destination wallet. So instead of going to the host or the proper user, it changes the destination wallet to its own. So as you can see the command here. So we tried to check the value of this wallet, and as of I think it just been used for a month. So the last payout was January 29, 2018, and it has been paid around 3.33 Ethereum. So on January, the value of Ethereum was, I think, around 1,000 US dollar, but now it dropped already. So by January, it earned around 3.3K US dollar in a month because of this one. And now we have the next variant. We call it OMG or OOMGA. So this turns IoT devices into proxy servers. So it contains still the original Mirai, so it can still attack. It has the killer and the scanner functions. Then it uses brute force to log in, so it don't have any exploit. Then we discovered this in February 2018. So it uses the 3proxy. It is an open source proxy server. And how does it turn the IoT device to a proxy server? So it generates 2 random ports for HTTP and SOCKS proxies, as you can see here. Then from there, it will try to allow traffic by, so for the proxy to work properly, so a firewall rule must be added to allow the traffic on the randomly generated ports. So once the ports are generated, they are reported to the CNC. So we have here the command to add the firewall rule to that port, that generated port. So this was also significant since cyber criminals can also earn money by renting out these proxy servers to other criminals who wants to hide their identity or their location. So next, we just sum up this Owari-Sora-Wicked-Omni variants since we believe that they were coded by the same malware author. So the author calls himself Wicked. So with his friend called Karma Afhoff. So Sora, this botnet uses Aboriginal Linux. So this is a cross-compiler. So it is much easier for the authors to compile the bot in different architectures. Then this variant commonly uses exploits other than default passwords. And one of the samples that we found includes 11 exploits in it. So again, we'll try to show a timeline. So maybe, I think it's too small. But The first that we discovered was Owari, so it was November 2017. So for this time, it was just using default passwords. But as 2018 came, it added exploits like every month. Then just June, I think this is June, so we found a sample that includes all these exploits. So this variant takes advantage of using known exploits. So these are all known exploits rather than discovering zero-day. Since this is also practical, since users don't usually update their products. And many users are just use and forget. So with the number of exploits in it, so how does this variant choose which exploit to use in the vulnerable device? So what it does is scan specific ports by initiating a raw socket scene. So for example here, it tries to connect to this port. So we have 8080, 8443, 80, and 81. So if it was able to establish or check that this port is open, it will use the corresponding exploit. So for example, port 88 is found to be open. It will use the RCE Netgear DGN1000 exploit. So it goes the same with other exploits mentioned. And to finish it up, so this one is just like from Omni botnet. So he was just mocking Brian Krebs. So this is the face of Brian Krebs here. So for vulnerability devices, so maybe he's targeting web servers or any. It tries to remove the HTML login.html here, the file here. So once it removes this one, it will download this one, meme. So this is the download URL, and it will replace it to be as the login.html. So if you're the infected user, then you go to your login.html, you will see this screen in your IoT device. So it says here, use stop right there. So want your router fixed? No problem. Send an email to krebsonsecurity@gmail.com, and we'll have it fixed ASAP. And Scarface is your daddy. And now some final thoughts on Mirai variants and our talk today. So we still expect more exploits that will be added. And then still more variants will be appearing. Then another thing also is a modification of encryption of configuration table. Since it's already predictable, maybe some malware author will try to change it. Then next is other means to monetize infected IoT devices other than crypto mining and proxy servers. So as of now, many have used, experimented, and modified the code for their own liking and purpose. Many variants want to have a piece of the IoT pie, and they are battling to compromise more and more vulnerability IoT devices. So the question still remains, who will be the next Mirai? Thank you.
And thank you very much, Rommel.
Yeah, thank you.
Are there any questions from the audience? Okay, if there are no further questions, please keep in mind that Rommel will be available for the rest of the day here at the conference to ask any questions that may come to mind later on. Thank you again, Rommel.